let's return to example 3 for a second. Now that we know that this fundamental theorem of calculus is in play, okay, this means that if we can take the antiderivative of this integrand, right, remember that's called the integrand there, if we can take the antiderivative of that, we can figure that out and then plug in a and b, right, in that order, the f of b minus f of a, then we could actually come up with a solution to this. Remember, we looked at this before, said, oh, how do we do that? All right, if it's a nice easy one like just 4x, we can figure it out. We can find the area of the trapezoid. But what if we come up with a better method that can work both for this difficult problem and the easy problem as well? Okay, so what we need to do though first is we need to get from f prime to f. We have to think of this as our derivative. We want to plug in the 1 and the 5, but not into this. We want to plug it into its antiderivative. Okay, we've got to go backwards. We've got to get to the original function. So we're going to go over all the rules in a moment. But before I do that, see if you can kind of picture this with me. Right? We see our first term is 4x cubed. 4x cubed is the derivative of what expression? All right? What do we derive to get 4x cubed? Now, some of you doing the power rule in your head, you come and say, oh yeah, that's the derivative of x to the 4th. 4x cubed is the derivative of x to the 4th. So therefore, the antiderivative of 4x cubed would be x to the 4th. So we know that this is the antiderivative of that term right there. Let's go to the next term. Well, first of all, we got a minus sign. Then we see 3x squared. 3x squared is the derivative of what term? Yeah, x cubed. X cubed derives to 3x squared. So 3x squared must derive to x cubed, or excuse me, must anti-derive to x cubed. All right? We see a plus sign. Then we see 2x. Okay? 2x, what would its antiderivative be? What expression derives to 2x? Yeah, x squared. So we got x squared right here. And finally, we see a 1. What expression derives to 1? Yeah, x. The derivative of x is 1. So the antiderivative of 1 is x. So this is like our original function. All right, that's our f of x. Now we want to plug our b and our a into this original function. So let's plug in the 5 and the 1. What happens when we plug in the 5? When we plug in the 5, we have 5 to the 4th minus 5 cubed plus 5 squared minus 5. Okay, that's our f of b. Now we can plug in minus, and then we plug in the 1. 1 to the 4th minus 1 cubed plus 1 squared minus 1. Right? 1 to any power is 1. So I'm not even going to bother to write the exponents. Okay. What are our values here? 5 to the 4th. 5 to the 4th, same thing as 5 squared. Squared, what's 25 squared? 625, yeah. Use your calculators on this. Okay. 5 cubed, remember that from MCAS, that's 125. 5 squared, we know what that is. And then we have minus 5. Over here we have 1 minus 1, which is 0, plus 1 minus 1, which is another 0. So that means we're subtracting 0 from everything. All right? 625 minus 125, well, that's 500. 525 minus 5 gives us 520. And if you use your graphing calculators real quick and you do math 9, all right, you can verify that the calculator is going to agree with you that the answer is 520. Before, we were relying on the graphing calculator to do everything. No longer. Now, we can solve this ourselves. But we got to get better. We have to get better at this idea of an antiderivative. So the next videos are going to kind of go over the antiderivative rules. Okay? But just to keep you in mind, when we're talking about antiderivatives, this symbol right here, without any numbers, okay, which is what we're going to see now over these next few videos, this means antiderivative. Okay, we've already talked about the definite integral, antiderivative. There we go. Okay, we've already talked about the definite integral, which is that same symbol, but there's an a and a b involved, a lower number and an upper number. There aren't going to be any numbers at this point. They're coming back, but not at this point. We're just going to see this symbol all by itself. And when you see that symbol with the function after it, that's known as the antiderivative. It's also be known as the indefinite integral, but for now, just think of it as the antiderivative.